So we're continuing in this video with showing biconditionals, and we're going to start with derivation 2.6 LRS 168. Okay, so we'll say show conclusion again. So this time we're trying to get P if and only if R. So we want if P then R and if R then P, and then we can apply CB to those two, which will give us P if and only if R, and that will be a direct derivation. So let's look at, too quickly, let's bring in our two premises. Neither of those are P if P then R. Now we can split these up though, because we can apply BC to them. And we get if P then Q and if Q then P. And we can apply BC to line 3, and we'll get if Q then R. And we can apply BC again, and we'll get if R then Q. You might be wondering, why don't we make an assumption here? Well, actually, sorry, let's back up. I'll come back to that. So we have these four conditionals, but we can't use any of them. We don't have P or Q or R for MP, and we don't have negation Q or negation P or negation R for MT. So the derivation is stuck. What we want, though, when we reflected on the beginning, is we want the two conditionals, if P then R and if R then P, and maybe we can get them from these. Now you might ask, why are we doing a subderivation? Shouldn't we do an assumption? And you could make this assumption P if and only if R, or negation P if and only if R, but what is that going to do for you? You don't have any rules that apply to line 2, right? So line 2 is kind of useless. You can do it, but it's almost never going to be. There are specific situations where it will be helpful, but not in the homeworks that we're doing right now. It's unnecessary. So let's just go ahead and get if P then R and if R then P. So let's show if P then R first. So we use our show conditional command, which says, oh, you're trying to show a biconditional? Well, I will write in either of the conditionals for you. Now that we're trying to show a conditional, it is a good idea to make an assumption, because this assumption, if P, this will probably help us. Now, we can say show consequent just to be in the habit, and again, we make an assumption here, because not negation R might be a very helpful assumption. So let's see if we can use P and negation R. Well, P we can use with line 4, because line 4 is if P then Q, so we can say 4, 9 modus ponens. Q we can use with 5 or 6, and if we use it with 6, we'll get R, so we can say 6, 12 modus ponens, and we get R. And so here we can say, oh good, that's a direct derivation of R. In fact, and then 10, we can apply CD to line 10, because 10 is the consequent of line 8. And there we go. Now we have one of the two conditionals. We didn't actually need to do this subderivation here. Let's see what it looks like if we get rid of it. Right? Because here we can get to R and then apply CD without doing that subderivation. So you don't always have to. So we did show cons to get the R, or to do a subderivation of the R, which is the consequent of line 8. It's not always necessary, but it never hurts, right? We did it with show cons. So now let's and it worked. Sometimes you need to do that, sometimes you don't, but it will never stop you if you do the show cons of, when you're trying to show a conditional, it always makes sense to say show cons. In this case, we didn't need to do it. Okay, let's look at the other. Well, we have if P then R. We also want to get if R then P, because that will let us apply CB to get the conclusion. So we'll say show conditional, and this time we'll choose if R then P, the second conditional. We'll say assume CD, and this gives us R. And we don't need to do the show consequent subderivation this time, so we'll skip it, because we can use R right away with 7 to give us Q. And we can use Q right away with line 5 to give us P. It's just two modus ponens application, if R then Q, and if Q then P. Well, given the R, we can apply modus ponens, and we get to the P, which is the consequent of line 13. So now we have the two necessary biconditionals. And now we want to put them together to form the biconditional, which is our conclusion, and then we can apply direct derivation. And there we go. Okay, so I'm going to do just one more derivation of this kind and then wrap up this video. So you might want to take a break and come back and watch that last derivation, or you can do it with me right now. We're going to go to 174. So this is 2.6 LRS 174. So this is a slightly more complicated problem, because if we look at this conclusion, the conclusion is a biconditional, but one side is now a disjunction, whereas the other side is just R. So in the previous examples, all of our the biconditionals always had on each side just sentence letters, but now we have P or Q on one side of the biconditional. So that's going to make this a little bit more complicated, but still completely doable. So let's bring in our premises. That's all the premises there are. We can't do anything with these. We don't have what we need for modus ponens or modus tollens. So let's go ahead and start showing the conditionals. Let's start with this one. So we want to make sure we break this down correctly. This is a conditional whose antecedent is P or Q. So we'll say assume CD. Now we look at P or Q and we're still stuck, right? We can't use P or Q. Yeah, there's no way we would need negation P or negation Q for MTP with 6. We're going to do MTP with it, and it's not the antecedent or consequent or negation of the consequent of 2, 3, or 4, so it looks like we can't get anywhere. So that means at this point we do need to do the show consequent, right? We're stuck. We should do a subderivation when you're trying, and if you're stuck and you have to do a subderivation, if you're trying to show a conditional, the best thing to do is to show the consequent of the conditional, because once we get that, we can say, we can apply CD to line 7 to box and cancel line 5. Right? When we apply CD, this happens. So we want to get R. And if we get, and by saying show R, we can now make an assumption, and this is going to make it easier to get R. So let's see if we can use negation R. Well, in fact, we can, because negation R is the consequent of line 2. So we can say 28MT. Not only that, negation R is also the consequent of line 3. So we can say 38MT. Now we have two new sentences, negation P or negation Q. Negation R won't do anything with line 4 because it's not the antecedent or the negation of the consequent of line 4. But now we want to see, can we use either of our new sentences, negation P or negation Q? Well, we could use negation P with line 4 for MT, but that would just give us not R back, right? We could say 49MT, not R. We already have this, so there's no reason to do that. If we want a not R, we could just say we could use line 8. But we can use not P and also not Q with line 6, because 6 is a disjunction. For MTP, you need the negation of either disjunct, and we have the negation of both of the disjuncts on line 9 and 10. So let's say 69MTP. We get Q. Well, look, there it is. There's a contradiction on line 10 and 11. We have a contradiction between not Q on line 10 and Q on line 11. So we can say 10, 11, ID. Right? We started with indirect assumption, and unsurprisingly, we just got a contradiction, which we can apply ID to, and that will box and cancel line 7. Good. Now this stuff is boxed. Let's get rid of it, or hide it. Not get rid of it, but hide it. So why did we do line 7? We want to use that show line immediately now that we've got it, because it's the consequent of line 5. And when you have the consequent of a line, of a conditional and a show line, you can apply CD. So we can apply CD to 7 to box and cancel 5. Good. All right. So we've gotten 5. So are we done? Well, no. We're only half done, because this is the left to right conditional making up 1. But now we want to show the right to left conditional. So now we want to show the other conditional, which has if R, then either P or Q is true. Okay, well, let's assume CD. So there's R. Can we use R? Not with 2, not with 3, not with 5, because all of those R is the consequent, but we can use it with 4. So let's see what happens if we use it with 4. We get P. Well, is P helpful? We could use it with line 2. That just gives us R back. We already have R, so there's no reason to do that. And we can't use it with 3 or 4. So what should we do? Well, we're trying to show a conditional. So we want to get P or Q to box and cancel. So one thing we could do is, let's say show consequent, because that would say, we want to get P or Q, let's try to show it. But we don't have to do that, because we can build P or Q, right? We have P, and so we can add Q on the right. And there's our consequent. There's P or Q. And so we can say CD. Good. So now we have both of the conditionals, and so we can apply CB to them. And that gives us P or Q if and only if R. And that is the conclusion. So there we go. Again, it's the same basic idea. We're going to show the two conditionals that make up this thing. we'll use the show cond shortcut to put in the show lines, and then they're just two conditionals, and we know how to show conditionals. You make an assumption for CD, and then if you have to, you do show consequent and make another assumption if you need to. Here we didn't need to make that second show line. We didn't need to show the consequent. We were able to get the consequent with an introduction rule applied to P. But either way, you assume CD and then apply and then if you want to, show consequent or need to show consequent. Once you're done with the two conditionals, you apply CB, which gives you the biconditional. So let's just summarize this back in our slides. So we saw if you want to get the two biconditionals, well, there's one main way, and that's by showing them. And so you want to show one conditional and you want to show the other conditional, and this show cond command will make those show lines for you. So that's how you want to approach showing biconditionals. And where do you make assumptions? You can make an indirect assumption off of the initial biconditional, but the more important assumptions to make are the assumptions you make inside of showing the two conditionals. You definitely have to do the assume CD, and then you may need to do a subderivation of the consequent of the conditional, and then do assume ID, as we did in a couple of those examples. So that's how you show a biconditional. Good luck with your derivations, and let me know if you need any help with these biconditionals.